Morning, Year 6, and welcome to a week of maths. We're going to do something different. Last week we were having a look at coordinates and various aspects of coordinates, one quadrant or four quadrants, translation and symmetry. Thought it might be nice to look at measure, and in Year 6 the measure learning is around perimeter, area and volume. I do know from some experiences on Flashback 4 and a few other questions like assessment questions that volume is probably an area that you haven't had a chance to look at. Before we embark on that, what I'd like you to do is pick up the entry assessment from Class Dojo and have a go at that, and then self-review, self-assess. The mark scheme is there, and identify, using a similar system as we have in class, where you do an assessment of which questions did you get right, tick, and which questions did you get wrong, dot. And is there a pattern to that? So are you, for example, doing really well on perimeter but less well on area? Now the entry assessment is an assessment of Year 5 learning, and therefore doesn't have all of the new learning. So see how you get on with that. And I also thought, just to mix things up, I'd like you to have a look at these activities, which again are reviewing your learning from Year 5. And because this is an area of learning that I'm thinking that you probably did miss out on due to a previous lockdown, I'd like you to choose some activities to have a go at. Now, there are quite a lot of them, so just to be absolutely clear, I am not saying do them all. So have a look through them, see what takes your interest, and then have a go. What I will do is I will send out the PowerPoint as well, so that if you are in a great position where you can print, you can do that. But as always, printing isn't necessarily required. Let's go and have a look at those activities. So because there are quite a few and they're choices, I'm just going to run through them. Each regular hexagon has a side length of 2 centimeters. Can you construct a shape with a perimeter of 44 centimeters? Investigate different ways you can make composite rectilinear shapes with a perimeter of 54 centimeters. Now, what that means is rectilinear shapes, so rectangles and squares essentially, but the composite, they're put together, so you can put them together in different ways. You could at home, can use some form of construction. If you have it, Lego, for example, it will be scaled down, or cut out some rectilinear shapes and do it practically. So here is a square inside another square. The perimeter of the inner square, so the blue one, is 16 centimeters. The outer square's perimeter is 4 times the size of the inner square. What is the length of one side of the outer square? How do you know, and what do you notice? So the value of C, marked on this rectangle, is 14 meters. And you're told that the longer side is 4C, which essentially means 4 times C. What is the total perimeter of the shape? The blue rectangle has a perimeter of 38 centimeters. So what's the value of A? you know that one of the sides is 4.8 centimeters, and you know that the parallel side will also be 4.8 centimeters. How many ways can you make different squares and rectangles with the same area of 84 centimeters squared? And what strategy did you use? So you could draw these out or cut some out and do it practically. Is this true or false? If you cut off a piece from a shape, like the green shape here, you reduce its area and its perimeter. Draw two examples to prove your thinking. So there we go. So if you cut it, have you changed the area? Have you changed the perimeter? Can you estimate the area of each shape and then order them from largest to smallest? The word I would just mention to you is the word estimate. In this one, each orange square has an area of 24 centimeters squared. So do these things. Calculate the total orange area. Calculate the blue area, and the blue area does have some relation to the orange, if you have a look. Calculate the green area, and what is the total area of the whole shape? So how many different ways can you split this shape to find the area? In this one, Jack says the shape has an area of 34 centimeters squared. Show that he's correct. You can either work it out mathematically or practically. So practically would be laying it or drawing it onto squared paper. Draw a circle on 1 centimeter squared paper. What was the estimated area? Can you draw a circle that has an area approximately 20 centimeters squared? Now you're being asked to estimate and do approximate. Some of you may want to find out mathematically, how do you find the area of a circle? Are you able to prove it? And the last choice today is, if each square represents 3 meters squared, what is the approximate area of the lake, the bunkers, the fairway, the rough, tree forest area? Remember, Year 6, this is about revisiting skills from Year 5, and I've presented to you a large number of choices. What you want to do is look at the time you have available. Once you've done your entry assessment and you've marked that, how much time do you have available of your approximately 1 hour to have a go at some of these? Any flashback 4 would be extra, so they take between 5 and 15 minutes. So you're spending somewhere between 65 minutes and 1 hour and 15 on maths today. I hope you enjoy that. I'm not going to send out an answer marking sheet, so please can I pass that over to you? Whichever ones you do, can you please send a photograph of your proof? Thank you very much. Year 6, have a great maths morning and take care.